Hello, and welcome to another State of Open subset. I'm Sal Kimmick, and I am a cybersecurity ambassador for Open UK, the industry organization for the business of open technology in the UK, open source software, open hardware, and open data. This is the 11th episode of the State of Open subset, where Michael Cade, a global CTO for Veeam and also fellow Open UK ambassador, will be talking to us about Canister, which was developed as an easier application-level data operations for Kubernetes. So if you care about data consistency, you will be riveted by this talk. I hope you enjoy.
Hey everyone. Thank you firstly for joining this session. So in this session, I want to talk about application level data management or data operations within Kubernetes. And obviously there's going to be that open source twist to it, is that, or how can we get that done? But also what are some of the trends that we're seeing in the ecosystem, in the industry, right through to the enterprise on how to protect these applications that require that stateful workload. So before we get into it, I'm Michael Cade. I'm a global field CTO. I work for Veeam Software. So Veeam Software is focused on enterprise data management. On the commercial side, I've been there for over 8 years. So I live and breathe data protection, fire, flood, blood type scenarios on a daily basis, and even more recently, probably more around cybersecurity, data security. And as much as there are accidental deletion and things that go wrong around our data sets, it's also obviously those big failures can happen, and cybersecurity, ransomware, and all of that good stuff also just ignites the reason for us to have that data protection strategy within our business, within our development life cycles as well, right? So I've been around the IT world for a fair while, mostly on the infrastructure and operations side, which is probably why I get that responsibility around data protection, because even more so recently, devs aren't necessarily too bothered about the data protection side. I think that's changing, and I think that's great, because it's not just about a backup and a recovery. It's about what else could we do with that? How could we clone that workload and do some cool stuff with it? Just a couple of other things. So I'm the author of 90 Days of DevOps. If anyone's just getting started in this crazy world of tech, DevOps is a great way of getting started. I put this repository together on GitHub, completely free, loads of open source tooling and projects that you can walk through. It's well over 23,000 stars now. So yeah, take a look at that. Also with that, I'm a huge fan, ambassador of what we're doing from an Open UK perspective as well, around open source tooling, open source hardware and software within not only the UK, because I think our message is getting further and wider with the group of people that we have. But yeah, very proud to be part of that. You can find me pretty much on all the socials. If you look for Michael Cade 1, one of the two, you'll find me. I look very different to the other Michael Cade that was in a TV program back in the 90s. Okay, with that's enough about me. Let's get into it. So, okay, Kubernetes really started that journey around stateless workloads, and I'm here to like debunk that myth, is that Kubernetes isn't just for stateless workloads today. It can absolutely be, but if we look back over the last 5 years, we've always had something resembling some sort of storage or stateful workload within our clusters, and that maturity is just continuing to happen. We've got the CSI framework, we've got volume snapshots, we've got stateful sets, we've got operators now for our biggest database providers out there. So you can see that there's a trend towards that. So I wanted to first of all break that myth down. We as Veeam, or we as Kasten, we have customers that are absolutely using databases in production, running inside of Kubernetes. Now, don't get me wrong, there's still a lot of customers out there, a lot of environments out there that are using databases still outside of that Kubernetes cluster. But I would argue that that's still an area that you need to be considering from a data protection point of view. Generally speaking, that database is going to be the most important, or one of the most important assets that you have within your environment. And just to put some names to those trending containers or those trending databases or data services, I should say. It's not just databases. For instance, things like Redis, Postgres, Elasticsearch. So yes, it's NoSQL, SQL type databases, but it's equally around messaging queues and logs and observability data as well. So if it's important, then what does bad look like? How do we get that data back as fast as possible? And if there's some stake to that workload, then how important is that stake? Can we afford to lose it if something bad was to happen? And bad being, that could be an accidental issue. Like, it's very easy to go kubectl edit if you haven't got the right guardrails in place. But equally, if you've got access to the database, you can do some pretty wild things in there as well. Okay, so when we look at consistency, what does that look like? So in theory, we could leverage storage snapshots, and we could just say, Mr. Storage Provider or Mrs. Storage Provider, I want to take a snapshot of my volume that is presented to my Kubernetes cluster. And that storage snapshot might be good enough, depending on what the application is. But remember, that storage snapshot is 9 times out of 10 is not going to be aware of the application that is being used. So if you're in a production environment and transactions are hitting that database, and then the storage snapshot takes place halfway through one of those transactions or through many of those transactions, then it's not going to be very consistent. It's not going to be consistent at all. It's like pulling the power cable out of that database server, as it were. Then we can start to go more towards the right of this presentation around application consistent, and that is where we're going to actually integrate into the application. We're going to tell something to freeze IO, freeze those transactions. Then we're going to trigger a storage snapshot. Namely, that could be via CSI, that could be directly into the storage array as well. And then once we're happy that we've got that grab of data, we're going to unfreeze the data service and let them transactions now hit the actual data. And then we move on to logical backup. So if we think about logical backup, as a lot of our database services, MongoDB, Postgres, MySQL, they all have a native tool that will allow them to dump out, maybe to a tar file or some sort of compressed file, a copy of all the databases that they have. If this is, so as we get more towards that, maybe that's what we want as a copy of our data. So a logical backup, meaning I want to trigger that logical backup to take place, which is also going to do that same app consistency, but it's not going to leverage the storage snapshot, potentially. So things like Elastic Dump is the example there. I use my SQL dump or PG dump as well, and then Mongo have something similar. Literally, all of a lot of the database options have some sort of native tool set that allows us to do this, and this is just going to allow us to orchestrate a full copy of that database or the databases on that server or on that container to be moved out to a different location. And then when we look at system consistent, now when we look at the world of Kubernetes, system consistent is going to involve not just the container and the stateful set and the system volume claim, it's also going to be looking at all of the other artifacts that build up that application. So there might be a web front end, there might be secrets, there might be config maps, there might be a load of different artifacts that build up this whole application. So in terms of a full data protection and consistency mind map kind of thing, I want to make sure I'm protecting the whole application. And depending on the application will depend on where you can get on this chart. Ideally, you want to be more towards that right, or maybe a mix of a few of these different options as well. Okay, so the premise of the talk was to introduce an open source project that we've been building at Kasten for a number of years now. And the reason why we're talking about it now is because of that trend of data services. But equally, we are on the cusp of, or we're in the process of donating Canister to the CNCF landscape, so the Cloud Native Computing Foundation, as a project. So it'll be a sandbox project on the CNCF, which will only allow us to raise more awareness around data protection in itself. So Canister allows domain experts to capture application-specific data management tasks in blueprints, which can be easily shared and extended. If you go to canister.io, pretty simple website, you'll see a lot more of the detail, but I'm going to run through a bit of a 40,000 foot view. We're going to show a demo about what that looks like. But where I'm talking about here, things like app consistent and logical backup, Canister enables us to achieve that. It allows us to freeze, take the storage snapshot in some instances, and then be able to unfreeze. But equally, it allows us to integrate into Elastic Dump or PG Dump and put that copy of the data out into maybe an S3 bucket or some sort of external location. So how does Canister.io or how does Canister orchestrate data protection? So it's a cloud native extensible framework for app consistency, and basically it gets deployed within your Kubernetes cluster. So if you've got many Kubernetes clusters, you're going to deploy Canister in each of them. The Canister controller, which is installed by a Helm chart, I'll touch on that shortly, is built up, or it works on 3 different areas. I'm going to go into these in a little bit more detail. We have the concept of an action set. This is going to be either a restore, a delete, or a backup. So those 3 triggers are going to cause us to we want to create an operation. An operation is set by an action set. A blueprint is defining the steps in which we want to take to be able to protect our application. So again, like I mentioned, and I'll show you an example, I think it's MySQL, but I equally show you in the demo as well what a blueprint looks like. And in there we have functions around backup, restore, and delete of those, so retention as well. And then we have a profile, and a profile is where do we want to store that data. So this could be an S3 repository, it could be an NFS export, and I'll touch on that. So basically 3 custom resource definitions that are deployed when you deploy Canister into your Kubernetes cluster, and it gives you that capability. The one thing I'll mention here is that there is no orchestration. So if you want to orchestrate this, schedule this, then you're going to have to look at other means in which to do that. And that could be a cron job, as simple as that, or it could be leveraging other tools to be able to achieve that. I've done a talk on how we could leverage Argo CD to drive the data protection, like incorporate that into your CD pipeline type thing. Okay, so what does it look like from an execution walkthrough point of view? First of all, it's a Helm chart. So Helm repo add, create that namespace, and then install. And then you've got those custom resource definitions that I just mentioned to you. From a blueprint point of view, on canister.io, or if you make it to the GitHub repo, you'll see a folder called examples, and you'll see stable. And there should also be a community folder there, which enables our community to upload new blueprints, tried, tested blueprints. And this will, as you can see here, there's a long list already, but this is our ask to the community. By raising awareness of this, not everyone has the examples that we have here. So the contribution wise is not only on the application itself, the application framework, but equally the blueprint contributions as well. And then whatever that database workload that we have deployed within our cluster. And I think that's another key point here, is that whereas maybe in the virtual world we were determined predetermined what database we would use, and then we would have to use that for everything. Like if that was a Microsoft SQL, if that was an Oracle, if that was MongoDB, we would try and cram all of those databases maybe into that one situation. Whereas in the cloud native world, we can pick the right tool for the right job, the right database for the right job, and I feel like that's very important here as well. So what does an action set look like? So in this example, this is going to create our action set CRD, or an action set within our Kubernetes cluster. For MySQL, it's going to leverage the MySQL blueprint. You can see that it's using the action within that blueprint of backup, and it's a stateful set of MySQL, and we're defining what that needs to look like, and also where the secret is as well, which will already be there as part of the application. So we trigger an action set, we kubectl create action set, however that looks like, I'll show you in the demo. We trigger that, the controller then goes, okay, let's go and find that blueprint. The blueprint will be deployed within the namespace, and then that allows us to use that canister function, that backup function, on that specific database workload. So pretty simple stuff. What that then looks like is we do what we need to do within that function. So whether that is an application consistent or a logical backup, it then exports that out into our object storage, our NFS, whatever that location profile needs to really look like. Then we go back as a controller and we say the action set was all good, or bad. Like either way, we're going to report that back to the action set so that when we query kubectl, we're gonna get that understanding of what's going on. Okay, that's enough slideware on Canister. So what I'm hoping will happen is, firstly, I'll touch on this. So there's CRDs that mentioned. We've got action sets, we've got blueprints, and we've got profiles. In this cluster, we have those three CRDs that I mentioned. We have a namespace with a stateful set, a persistent volume claim, and a pod in a namespace for Elasticsearch. I think it's called ES test or ES demo. And then we have our canister namespace, which consists of one pod and the namespace within that. We then have our CRDs, and I'll touch on that as we talk over the top of this. So before I do this, there is a way in which, so natively within Kubernetes, we have the ability to leverage volume snapshot classes. So maybe one of the questions that you ask is, well, why wouldn't I just use that? Why couldn't I just take a volume snapshot of my Elasticsearch namespace and the PVC and everything within that? And if anything goes wrong, we can roll that back. And that would just be the PVC. But that would be in a crash consistent state because we're not talking to the Elasticsearch pod to coerce that workload. Coercing meaning we're pausing I/O to that. So first of all, the last diagram explains how I have my existing cluster. So you can see here that I have ES test and I have canister as well already deployed. I also have min.io, which is where I'm going to store the data. Big caveat here is that I'm using Minikube, great open source tool. Never send your backups to the same cluster. Maybe I'm not using Minikube, but yeah, on that, big shout out to that but just don't send your backups to the same one. So you saw there that I've already got the canister Helm chart added, or I've just added it. So now it's the time to install that canister operator into a canister namespace and create that namespace. If we then do a kubectl get pods against that namespace, you'll see that we're in that running space, and then now we're into that state that we were in the slide before. So next up, I want to show you that we have those three CRDs that we've just deployed via that Helm install command. So you can see action sets, blueprints, profiles. We can then create a profile of that min.io bucket. So you can see here S3 compliant, and then it puts out the details to that. I've actually got this documented as well, and I'll get that shared. So I have a profile. We can have multiple profiles. So if min.io is an option for on-premises, but then maybe you want to send it out to AWS S3, no worries. Then the blueprint, very hard to see. I suggest going to canister.io and having a look at that blueprint. But what you'll basically see in this blueprint is you'll see a number of actions. You'll see the backup action, you'll see the restore action, and you'll see the delete action. I probably went over that very quickly. So basically in each of those functions, we have the ability to do something, i.e. we're going to coerce the workload, we're going to delete the restore point. So we've created that blueprint as well. And we've added that to our canister namespace. And then we're going to jump into our Elasticsearch pod because I want to actually show you some data. So you can see here that we have some data that we're exporting out into our environment. You can see here, I think the one that we want to look at is John Smith. So you can see, and then just take note of these numbers, because basically what I'm going to do is so there we go. We've added John Smith as a customer into our environment, and then we're going to go and take a backup of that, and then spoiler alert, we're going to go and remove that from the database or from the data service, and then we're going to recover it using Canister. So next up, we want to create one of those action sets that is going to enable us to do that. So first of all, we have our profile. We're going to need that name as part of our action set. So we're going to create our action set using using that profile, but equally using the blueprint as well that we previously. And what we're going to use here is another CLI that is part of Canister, and that's going to create that action set, a backup of the namespace, the blueprint, Elasticsearch, the stateful set ES test, and so on to be able to create that. Now, if we go and look up that action set, you can see here already there's not a lot of data in there, so it doesn't take too long, but you can see that the status is complete. If we go and look at Canister, we should hopefully see a tar file in there, or a zipped up file of our backup, very tiny, because this is just obviously a simple demo. So next up, I want to cause an issue, cause a failure scenario against this disaster strikes. So what we're going to do is we're going to, I think I exec into this. Yep, so we're going to exec into it. We're then going to manipulate that data, which when you think about accidental deletion, like we could absolutely do that. There you go. We've deleted our store. A bit more dramatic than just removing John Smith. We could have done that as well, but we actually just removed everything from that point. So now our database is down, but Kubernetes is obviously still serving the data, doing everything, like the persistent volume claim, the pods, everything's all good. But our database is clearly not in a healthy state per se. It doesn't have the good data. So you can see here was our action set that was completed. This was our backup action set. We're now going to create a restore action set that enables us to restore that data. So you can see the command that I'm putting in there. This is just really saying I want to use this as my restore point that I want to bring back. So we're now going to create an action set, which is an action restore in the namespace Canister from backup action set that we set as an environmental variable. Now, you can see that it was created. If we then go and see all of our kubectl get action sets, you'll see now that I have a restore there with the progress of 10. Well, it should be 100%. It was complete. And now if we jump back into our application, fingers crossed, with a recorded demo, you'd hope I'd get this right. But the idea is that our data is going to be back, and we can carry on our day and carry on transacting our mission critical data. So let's jump back in. Let's run a curl command against that, and hopefully we're back up and running. You can see, yeah, we've got the indice up and running and showing, and then we've got our customer list of a massive list of John Smith there. And with that was the demo. So hopefully that gives you an insight. And there's a reason why I chose Elasticsearch as well, because Elasticsearch obviously Elasticsearch gives us, it's not just about databases as much as there is a database behind Elasticsearch. It's a data service more than anything. So, and when you look at that list, that like there's Redis in there as well as like MySQL and other stateful workloads as well. My only ask to the community is take a look at, if you've got a PVC, how important is the data within it? And if it's important, then you should be backing it up. That's probably my biggest takeaway from this. Okay, so where do you go from here? So if you're a developer, if you're operations, if you're DevOps, Canister is a cloud native, open source, extensible framework for Kubernetes data protection. Hopefully I just showed some of that. That QR code is going to take you to canister.io, I hope. We also, from a community point of view, and this has been going on for the last year already, these bi-weekly Zoom meetings. There's also a Slack channel that you'll see from canister.io. We have hands-on tutorials using Kube Campus, and then that list of example blueprints. My biggest ask is go and try them out. Let's see what you find and adapt them, enhance them, play around with them, give us feedback on them. We're more than happy to help on that front. Okay, so how do we get started? Super easy. Clone that GitHub account if you wanted to be add and look at functionality of that. install that into your environment, look at the blueprints, etc. Just get involved. Let us know what you're doing, what you're seeing. If you're stuck, let us know. We want to help on that front as well. Last 20 seconds, and this is just because I have to, because I'm paid for it. So, as part of Veeam, we obviously offer the orchestrated way of being able to protect those in an enterprise environment. We do have a 5 worker node free license that enables you to have full functionality over 5 worker nodes within your cluster. We exclude control plane, so if you've got 3 control plane nodes or more, that it doesn't matter. 5 worker nodes is our limit for full functionality. Obviously, we can then get into scalability and enterprise support for around that. Biggest part there is that we absolutely use Canister as part of that commercial product, and it's a small subset of that. Where I mentioned around Canister doesn't have the orchestration and scheduling, Cast and K10 brings that capability into the fold. And I think with that, that's me done. Thanks for watching.
All right, everyone. Thank you so much for taking the time to learn more today. And Michael, thank you for taking the time to tell us more about the knowledge and resources around data consistency, particularly with the walkthrough. And now we can all start learning on our own keyboards today. I'm really excited about that. And tune in next week for our next State of Open subset. Thank you.